freezing winds, endless ice, and the coldest temperatures on Earth. Welcome to the Earth's polar climates. These are the vast, frozen worlds that hold the coldest, driest, and most extreme weather on the planet. Let's explore Köppen's climate, and why these icy extremes matter more than you think. Welcome to another episode in our climate series, where we explore Earth's diverse climatic zones through the lens of the Köppen classification system. Today, we focus on polar climates, classified as Group E, the coldest and most extreme climates on our planet. If you're passionate about geography, earth science, or just want to know how our planet really works, you're in the right place. Before we dive in, give this video a thumbs up and subscribe so you don't miss out on more deep dive climate content. So, what is Köppen's climate? Köppen's climate, also known as the polar climate zone, is defined by one key criterion: the mean temperature of the warmest month is below 10 degrees Celsius or 50 degrees Fahrenheit. In simpler terms, it never gets truly warm, ever. Located at the highest latitudes, polar climates receive very limited solar energy throughout the year. The sun's low angle, combined with high reflectivity of snow and ice, prevents substantial warming of the surface. Unlike the tropics, which are defined by intense heat, polar climates are distinguished by unrelenting cold. As a result, these areas experience the coldest summers and the lowest annual temperatures on Earth. Although these areas receive little precipitation, they are not classified as arid in the Köppen system. This is because the extremely low temperatures result in minimal evaporation, which maintains the region's moisture balance. Recent research indicates that the climates at high latitudes are experiencing more rapid change than those in other zones. This highlights the critical role these regions play as indicators of global climate shifts. Polar climates are divided into two distinct subtypes based on summer temperature thresholds: the tundra climate, labeled ET, and the ice cap climate, labeled EF. Let's begin with the tundra climate, denoted by the code ET in the Köppen classification. This climate occurs mainly in the northern hemisphere, including the coastal fringes of the Arctic Ocean, Arctic Islands, northern Iceland, and southern Greenland. In the southern hemisphere, tundra climates are far less common but can be found in the Palmer Peninsula of Antarctica and near the southern tip of South America. Interestingly, tundra climates are not exclusive to the polar latitudes. In some high-altitude regions, such as Himalayas and Andes, the same cool summer conditions occur. These areas, known as alpine tundra, experience milder and less distinct winters compared to their polar counterparts, though they still fall under the ET category. The 10 degrees Celsius summer isotherm defines the outer boundary of the tundra climate and also corresponds with the tree line, beyond which trees are unable to grow due to insufficient warmth. In these areas, the vegetation is dominated by grasses, sedges, mosses, and lichens, which thrive during the short summer months when the ground thaws enough to support life, before becoming dormant during the long, freezing winter. Below the surface lies permafrost, or soil that remains at or below 0 degrees Celsius or 32 degrees Fahrenheit for at least 2 consecutive years. In most tundra regions, only the top meter of soil thaws each summer. Permafrost creates significant construction and engineering challenges. When disturbed, it can begin to thaw and become unstable, leading to building subsidence, cracked roads, and even landscape collapses. Tundra climates are characterized by long, cold, and dark winters, with short, cool summers during which average temperatures range between 4 degrees Celsius and 10 degrees Celsius, or roughly in the 40s Fahrenheit. The annual temperature range in these areas often exceeds 30 degrees Celsius, or 54 degrees Fahrenheit. Precipitation is low, usually less than 25 centimeters, or 10 inches, annually. These climates are often enveloped in sea fog and radiation fog, which form due to frequent temperature inversions and cold air near the surface. Frost can occur in any month of the year, even in the middle of summer. The climatic controls in these regions are unique. Due to the high latitude, the sun can remain above the horizon for months during summer or disappear completely during winter. This causes long periods of daylight or darkness and minimizes daily temperature fluctuations. The air tends to be dry, and large-scale anticyclonic conditions frequently suppress cloud formation and precipitation. Next, we turn to the ice cap climate, designated as EF in Köppen system. In these areas, no month has an average temperature above 0 degrees Celsius, or 32 degrees Fahrenheit. The result is a landscape where no vegetation can survive, and ice and snow cover the ground permanently. EF climates are found over the massive ice sheets of Greenland and Antarctica, and together, they cover approximately 9% of Earth's land area, totaling about 15.5 million square kilometers. Average annual temperatures in these regions are staggeringly low. For example, ice melt in Greenland averages -29 degrees Celsius, or -20 degrees Fahrenheit. At Bird Station in Antarctica, the average is -21 degrees Celsius, or -6 degrees Fahrenheit. At Vostok Station, one of the coldest places on Earth, the average is -57 degrees Celsius, or -71 degrees Fahrenheit. In fact, the lowest temperature ever recorded on Earth was measured at Vostok, -88.3 degrees Celsius, or -127 degrees Fahrenheit, on August 24, 1960. Several factors contribute to such extreme cold. These regions lie at high latitudes, which means they receive very little solar radiation. They are also situated at high elevations. Ice melt, for instance, is nearly 3,000 meters above sea level, and much of Antarctica is even higher. The constant presence of snow and ice reflects up to 80% of incoming solar radiation, preventing significant surface heating. Furthermore, any solar energy that does reach the surface is used to melt ice rather than warm the air. A distinctive meteorological feature of EF climates is the katabatic wind. These are gravity-driven flows of cold, dense air that descend from high ice sheets. These winds can be so strong that they override normal pressure gradients and create near-constant blizzard conditions. EF climates exhibit some of the harshest conditions on Earth. There is no vegetation, as nothing can survive in soil that is permanently frozen. All months remain below freezing, with average winter temperatures ranging from -34 to -51 degrees Celsius, or -30 degrees Fahrenheit to -60 degrees Fahrenheit, and extremes dropping below -73 degrees Celsius, or -100 degrees Fahrenheit. Despite the snow and ice, these are technically polar deserts, receiving less than 13 centimeters, or 5 inches, of precipitation annually. Because the air is so cold, it can hold very little moisture, which limits precipitation even further. And, most of the snow you see has been there for years, even centuries. The climate is dominated by stable air masses and strong surface temperature inversions, with the coldest air trapped close to the ground. Now, let's answer the big question: why does any of this matter? Polar climates might seem distant and unrelatable, but they're crucial to Earth's climate system. These icy regions regulate global temperatures through their albedo effect. They also influence ocean currents, sea levels, and atmospheric circulation. And here's the urgent part: polar regions are warming faster than anywhere else on Earth. The loss of permafrost, melting glaciers, and shrinking ice sheets could trigger feedback loops that accelerate climate change globally. What happens in the Arctic and Antarctica doesn't stay there. It affects coastlines, weather patterns, and ecosystems worldwide. So, understanding Köppen's climate isn't just about geography, it's about understanding our planet's future. In summary, the polar climates, designated as Group E in the Köppen classification, represent the coldest and most uninhabitable regions of our planet. The tundra climate allows for limited plant life and seasonal thaw, while the ice cap climate is locked in a state of permanent ice and sub-zero temperatures. Both of these climates are shaped by extreme latitude, high reflectivity from snow and ice, and minimal solar input. As the polar regions continue to warm rapidly, they offer crucial insights into our changing climate and the future of our planet. If you found this video informative, please like the video, subscribe to the channel, and click the bell icon to stay updated with our latest climate explorations. Thanks for watching, and stay curious.